right, so now we're moving on to the next lesson on deductive reasoning. And deductive reasoning always makes me think of kind of like Sherlock Holmes, although I think technically speaking he used a slightly different form of solving his cases. But you know, solving a crime, you're looking at proof, you're looking at things, and you want to get to the meat of the matter and find the motive or whatever. You're deducing the reasoning for that crime from the clues left behind. So let's take a look at what deductive reasoning is technically. It's the process of showing that certain statements follow logically from an agreed upon assumptions and proven facts. So I showed a picture of the court case because again, when you take somebody to trial, before they can be found innocent or guilty of the crime, in the US we have the idea that you are innocent until proven guilty. So in order for a jury or a judge to agree to prove you guilty, they have to believe and have the facts presented to them proven in order to then deduce, okay, this person is guilty. So deductive reasoning is used quite a bit. And we use it in geometry, a combination of inductive and deductive reasoning, where we find the patterns. We use inductive reasoning to find the patterns, to make conjectures, and then by applying those conjectures into new situations, we use deductive reasoning to prove the statements. Geometry is all about proof. So let's take a look at the next slide. We've actually already used deductive reasoning several times before. In algebra, we used it all the time. We were following a set of rules in order to solve the situation, to solve the equation. Now, by putting the reason for each step in the process, you're proving your statement. So when I say, okay, how did you get that answer? You have to prove it by saying, first I did this, and then I did that, and then that led me to this, so on and so forth. So let's take a look at this example to go through. If I wanted you to solve for x, the first thing we want to do is go through our order of operations and get rid of the parentheses. So step one is we would distribute. So that would be step one of our proof of why we are doing something. So distribute the 3, distribute the 2, add the 7 because it's still part of there, and then we have whatever else is going on the equal side. Now, step 2, I have all those x's, I have all those numbers, I need to combine the like terms. So, 6x plus 4x, it's 10x on the left, nothing on the right-hand side that I need to worry about just yet. 3, 2, and 7 would give me 12. So the left-hand side is simplified. 42 minus 5x is already simplified. So I've combined my like terms. I've added all the x's together, and I've added all the constants together. Then, to go through the process of solving the equation, I need to move all the x's to one side and all the constants to another. So easiest one to do first, get rid of that 12. So I'm going to subtract 12 from each side. And because it's an equation, that's why we're doing each side. That's the agreed upon rule that we're following. So 10x is equal to 30 minus 5x. I don't have all my x's on one side, so let's add 5x to both sides. So the fourth step is that we're adding 5x to each side, following the rules of equations. And that's going to give me 15x equaling 30. So my final step is I will divide each side by 15. So 15x divided by 15, that was really annoying. I don't know why I keep saying that. Is 1x, and 30 divided by 15 would be 2. So x is equal to 2. So there's my solution, and here is my deductive reasoning of y. Following the already determined patterns, the already determined rules, I deduced that x is equal to 2. So again, you've been doing this already to solve your problems. Now we're just going to take it one step further and apply it to geometry. All right. Now, hopefully, if you haven't already had your notebook out, you do have your notebook out now, because you're going to be adding, after this example, our first conjecture into the notebooks. And so you want to have a list of these conjectures, because you are going to use them later to make proofs. So this is an example where we first have to use inductive reasoning to determine the conjecture, and then later that conjecture will be used in our deductive reasoning. It says in each diagram, ray AC, when I was typing this I couldn't make the ray sign, bisects obtuse angle BAD, so classify angle BAD, DAC, and CAB as acute, right, or obtuse. Then complete the conjecture. All right, so it tells us in the instructions that angle BAD is an obtuse angle. So we can look at our examples down here and see that yes, every angle BAD is obtuse because it's greater than 90 degrees. Now it tells us that AC is bisecting this angle. So that means then angle BAC, they call it CAB, but I go left to right, is congruent to angle DAC. So this is congruent to this. So that means if I take 120 degrees and I divide it by 2, those two angles are 60 degrees each. So in our first picture, angle CAB is an acute angle because it's less than 90. And angle DAC, since it's congruent to CAB, it is also an acute angle. All right, let's look at our second one. Angle BAD is 158 degrees, AC is bisecting it, so this is equal to this. 158 divided by 2 is 79 degrees. 79 degrees is less than 90, so that means angle BAC or CAB, however you want to call it, is acute. And angle DAC is also acute. All right, our third example. Angle BAD is 92 degrees. So almost a right angle. Looking at the picture, you would almost, if you didn't have that measurement, if this was covered up, you would think, maybe that's a right angle. This is why you can't just make assumptions. You have to have the markings. Since we don't have anything telling us there that it's a right angle, we in fact actually have something telling us it's 92 degrees, we know that this is an obtuse angle. AC is bisecting, so this angle is equal to this angle. So 92 divided by 2 would be 46 degrees. All right, so, well, 46 is less than 90, so again, angle CAB is acute, and angle DAC is also acute. So, 3 different examples, varying degrees of measurement, but they were all obtuse angles for angle BAD, and when we bisected them, they all created acute angles. So our conjecture that we can make, and this would be the first one to put in our notebook under the list of conjectures, would be, if an obtuse angle is bisected, then 2 newly formed congruent angles are acute. I would recommend writing that sentence word for word and perhaps drawing an example. All right, and that is it for this particular lesson. As we continue forward, we'll be adding more conjectures into our list that you will be required to know in order to solve future problems.